Welcome everyone. So at last having a chance to say formal hello to all of you. So I will be leading this project along with Dr. Momin and your TA Hassan Amin. So I will explain briefly what is the idea behind Track My Fitness project, how we are going to execute it, and what are our expectations from you guys, all those groups who are going to adopt for this project. So I will start. Uh, I will not go in a lot of details because after this round of presentations in the meeting slot, I will be there if you have very specific questions that how, for example, you are going to use thresholds or coding or algorithmic flow, everything else. So I will only introduce main idea just to motivate your interest and enhance your curiosity. So what is the idea? So the idea is, just let me see. Okay. Sorry, guys. I hope I will be able to. My iPad is stuck. Okay, so here we go. So the idea is uh, we want to develop a framework in order to identify the accurate form of weightlifting exercise using data from wearable devices. Okay, I will explain it very intuitively. Suppose you are in a gym, right? And you are doing some exercise. So especially the beginners, how do you know that whether your form is correct or not? Of course, you take feedback from a gym instructor who is qualified enough to guide you. For example, this should be your angle, this should be your movement. You should not be lifting a lot of weight from the beginning. So the idea behind this Track My Fitness is let's automate this project. Let's automate this feedback process. But how we can do that? So we can do that by recording the motion. Means if we are able to track this motion over the time, then the tools that you have already studied in EE100, like basic signal processing tools, filtering, FFT, analyzing the frequency contents, etc. Using those basic tools, you can actually tell whether the user is performing this exercise in correct form or not. Okay, so that is the idea. Now, the question is how we are going to track this motion over the time. So that is not so simple, motion tracking. But fortunately, there are some areas in computer science and electrical engineering, for example, augmented reality, virtual reality, and computer gaming, which has so much enriched this field that we have a lot of sensing technologies which help us in tracking the motion of any object. So I will briefly describe two types of categories which we can use to track the motion of any object. So first is, of course, optical tracking systems. So what do we have in optical tracking systems? We have cameras installed, like as you can see in this diagram, uh, all around the subject. And using very sophisticated video processing tools, we can tell that, okay, so where is the object, what is the specific angle of execution, etc., actually in 3 dimensions. So I have also listed some very sophisticated technologies here. Maybe you guys know about Microsoft Kinect. They are actually based on optical motion tracking system. And I hope some of you also knows that ICC, International Cricket Council, also has a lab installed in SSE LUMS, which exactly uses this type of technology to track the bowling action. So we have guys from EE, our faculty colleagues, also from computer science department, who are very actively involved in that lab. So, but the problem is Whenever you rely on optical motion tracking systems, you need very sophisticated cameras. When I say sophisticated cameras, it means their cost is in lakhs, not in thousands, or even more than that. So, of course, we cannot do that in a gym setting. So, what else we can do? So, we have non-optical motion tracking systems. So, there are some sensors which you install in uh, in these devices which are available in commercially off the shelf scenarios. So the characteristic is they record the motion. So the motion can be linear or angular motion, or there is also some other thing that I will touch shortly. Using these devices, we can record angular and linear motion. So what is the main device which is used in these technologies? We call it IMU, which is inertial measurement unit. So now on next 5 to 6 slides, I will introduce you guys what is this device and how it can be used as an alternative to optical systems, which is camera. So these are very cheap devices, which of course you have in your mobile phones. You have in every device which you can expect a motion, for example, in cars, in aeroplanes, in rockets, everything that you can imagine. But the interesting thing is IMU range from $1 to around thousands and even millions of dollars, because they have some inherent issues due to which they can be used for a particular application or they cannot be used. I will explain that shortly. So we will be focusing on this very small device IMU, which you can attach with anybody. For example, here with the dumbbell that this guy is using, and then you can start tracking its motion. So what is an IMU? So IMU is basically a sensor to record the motion. So when I say motion, we mean two types of motion. One could be linear acceleration, one could be angular acceleration or angular velocity that we are familiar with. So as you can read, IMU has basically three components. We call them gyroscope, which is used for angular motion, accelerometer used linear motion, and then we have magnetometers, which are basically used to record the strength of Earth's magnetic field, which is different at different locations. So the third one, magnetometer, can be indirectly used for what we call fingerprinting. So if you have any question about that specific magnetometer thing, because it is very interesting, I will answer at the end of this talk. So what IMU provides us? A single IMU has basically 3 gyroscopes, 3 accelerometers, and 3 magnetometers. So there is basically no rocket science in understanding why we have these triads instead of single, because in our real world we can record motion in x-axis, y-axis, and z-axis. So for this motion, if we have to record a motion completely in 3 dimensions, we need at least 3 devices. So they are attached with each other at 90 degrees. They form this single device, which is called IMU. So single IMU, 9 sensors, 3 are responsible for recording angular motion, 3 are responsible for recording linear motion, and 3 are responsible for measuring Earth's magnetic field, which is different at different locations around us. Okay, so in total, we get 9 signals from single device. Now it becomes a challenge because you will be getting these signals or this data, as you already know from your sampling lab, that this data will be in digital form or in discrete time form, that you will be getting these samples. So you have to record those samples, and then you have to process those samples in some software before you can make any intelligent decision or guess on the type of motion that guy is executing. Okay, so first let's see what are gyroscopes. So gyroscopes provide us angular rate of rotation in degrees per second. So for example, how much this guy is twisting its arm in I don't know, 1 millisecond. So it depends on what is your sampling frequency that you are going to use. So we have to record this rate of rotation in 3 axes because we have X, Y, and Z axis. So the notation that is typically used is the rotation around X axis, we call it pitch angle, as here it is mentioned in red. The rotation around Y axis, we call it roll angle. And the rotation around Z axis, we call it yaw angle, pitch, roll, and yaw. So pitch, roll, and yaw, they are angles in degrees or radians, but gyroscopes provides us their rate, means degrees per second or radians per second. So that is what we get from gyroscopes. Then, since there are 3 gyroscopes inside one single IMU, what you will be getting is 3 different signals over the time during any experiment. So this will be a curve that you will be getting for x-axis, y-axis, and z-axis. On y-axis, you have rate of rotation, which is the output of gyroscope, and on x-axis, you have time, and you will plot it in MATLAB. 3 different plots. So I have used here, what do we call? Hold on operation that I am sure you are familiar in MATLAB. So these are gyroscopes. Now gyroscopes provide us degrees per second. If I do a simple mathematical calculation, I take the x-axis gyroscope reading, I pass it through something, I get degrees or radians. So there is no rocket science that how can we convert a degrees per second into degrees. Okay, you simply have to integrate it. But the problem here is gyroscopes, especially those that you have in your mobile phone, have a drift associated with it. So when you integrate it, that starts accumulating and you get very bad angle measurements if you simply use integration. Then we have to use some other measurements to correct that angle. But that is not the part of this project. Just I am telling you for the sake of curiosity. Same can be done with other 2 gyroscopes, gyroscope Y and gyroscope Z, so that you get 3 different angles, pitch angle, roll angle, and yaw angle. Okay? So a single gyroscope means you have to measure the rotation around X, Y, and Z. So you also have rotations per second, and you also have these absolute angles in degrees. Okay, so what I'm doing, I'm going to introduce you guys the type of signals that you will be seeing in this project if you adopt for it, and how you will be using them. So after that, we have accelerometers. So accelerometers give us linear acceleration, and we know that linear acceleration, we measure it in terms of meter per second square. So when you apply a force on a body, how much it undergoes an acceleration. Using a simple Newton's law, we can actually compute this acceleration, and then we can calibrate it for any sensor. So linear acceleration could be in 3 dimensions. So we can have linear acceleration in x-axis, in y-axis, and in z-axis, right? So again, we have 3 different signals. But this time, we don't have those angular things. We have those linear things, which we call meter per second square. Now, what I can do some processing on these 3 signals to get what we call total acceleration. That, for example, you say that a car is going to accelerate at some rate. So how do you get that rate? Simply, you take these X, Y, Z, you scale them, you take their, what we call it. So this is simply the length or the amount of acceleration a body that undergoes over the time. So this you have to do it at every time instant. Okay, so this signal we can also produce using IMU. Then the third sensor, that is magnetometer, provides us basically Earth's magnetic field vector measured in Tesla or micro Tesla unit. So we know that Earth has its own magnetic field, which is present around us. So how we can measure it? We can simply use what we call compass. So compass is nothing but its fancy name is magnetometer. So using that compass thing, we can measure this Earth's magnetic field. So when I change my, if for example, if I have compass attached to my Apple Watch or something like that, so when I start moving that device, so the Earth's magnetic field is going to change, especially indoors, because in indoors we also have other magnetic field which is going to interfere with that Earth's magnetic field, right? So we can also measure that thing. And similarly, since Earth's magnetic field is a vector at any point. What we can do, we can measure these vectors in x-axis, y-axis, and z-axis. Okay? So the unit is Tesla or microtesla. So using a single IMU, we get 9 different signals which describe the motion of any object completely in 3 dimensions. Now, how we can use them? So for this project, let's use 4 different IMUs. Okay, since we have to track the motion of this guy, which is doing some exercise in gym. So what we do, we attach 4 IMUs, one on belt, one on armband, one on the weight or dumbbell that he is going to carry, and another one on glove. Okay, and we ask him where all of these 3 variables and perform exercise using this dumbbell on which this sensor is attached. Okay, so single IMU 9 signals, 4 IMU 9 multiplied by 4 signals. We are going to increase the dimension of our data. So you need to be very careful in tracking the data dimension. Okay, so after that, let's start the experimentation. So here in the sketch, you can see you have a single IMU attached to what we have. We have here this dumbbell, then we have here on the armband, then we have on the glove, and then on the belt. Okay, so in the data that you will be using, the nomenclature that has been used is belt, armband, glove, and dumbbell. Okay, so they refer to a different type of IMU. So we have asked the 6 different participants to perform a single exercise. Let's focus on single exercise at the moment. But what you will be developing as part of this project can easily be extended to other exercises as well. So it is just to keep the complexity of the project in limits. So how to perform this exercise? So we selected this unilateral dumbbell bicep curl. So where the subject has to simply take a dumbbell and then move it in the fashion of bicep curl and then move it back. Okay, but in 5 different fashions. Class A, first fashion, we say that this form is a correct form. How do we know this is a correct form? So we basically ask an experienced gym instructor to let the guy execute this form in proper form. Okay, exactly according to the specification provided. And then in 4 other forms, each participant is asked to make these 4 common mistakes. So for example, class B corresponds to mistake in which he is going to throw his elbows to the front rapidly. Class C, lifting the dumbbell only halfway, not executing it properly. And similarly, class D and E, you can read the specification here. Okay? So among these 5 classes, only class A corresponds to the specified execution of the exercise, while remaining 4 classes correspond to common mistakes that usually beginners make when they start doing any exercise in the gym environment. So since we have attached these 4 sensors to the guy who is doing the exercise, we can start recording the signals. So when we will perform how many experiments? So the data that we are going to provide you, it contains 864 experiments using 6 different participants. And each experiment produces discrete time data from these 4 IMUs at a sampling frequency of 45 Hertz. In the manual, you will see all the details about it. So it means that, so I know, I'm sure you guys know, but does it mean sampling frequency of 45 Hertz? So it means in 1 second, you have 45 samples. Okay, so that is Hertz per samples per second. Now, taken together, the data related to each experiment is provided in 56 columns with necessary labels. So you have access to this data as 56 columns uploaded on LMS portal. When you will read this data in MATLAB, you will get something like this. So you will have FS, which is common for every sensor. Minimum number per experiment. So this is a variable that you will be using as explained in the manual. And then you have this T. You can see that T is a structure or an array which has 39,242 rows and 56 columns. So each column corresponds to one different IMU signal. ठीक है, तो आप कॉलम्स के जब नाम पढ़ेंगे तो उसके ऊपर लिखा होगा कि दिस इज आर्म बैंड IMU, or this is belt IMU, or this is glove IMU, or this is dumbbell IMU. ठीक है, उनके आइलर एंगल्स भी हमने आपको प्रोवाइड कर दिए हैं साथ में. एंड वी आल्सो हैव प्रोवाइडेड द टोटल एक्सेलरेशन एज आई हैव एक्सप्लेन्ड इट इन माय स्लाइड्स. नाउ what you have to do, the task is you have to come up with some algorithm that we are also going to guide you, that uses some features from these 56 signals. The 56 columns are data ke, those are 56 signals as I am referring to them. So using some features which you will be computing on these 56 columns, you have to differentiate between, number one, whether the user is going to execute this exercise in correct form or wrong form. Okay? This is first main task. There are also some subtasks which will lead you to first main task, and this first main task will lead you to second main task, which is to identify the type of error that any particular guy is executing during that exercise. Okay, so these are the main two tasks which you will be doing in this project. So I will be available from 4 to 5 on the meeting link that I'm sure Mumin is going to share with you guys shortly. So we can discuss more about this project and what are those features, how you are going to compute them, what is the algorithm that you will be using, and all that stuff in that Power 5. So even now, if you have any question, you can raise your hand or let Dr. Mumin moderate the session.
Andy, so maybe this is more attractive for people who are gym buffs. Maral, if there are questions, please go ahead. We can take some questions now. Um, Very broad level questions. And if you have specific questions about what you're going to have to do, we can take them towards the end. And I'll share details with that or for that in a little while. Any questions you may have for Tahir? All right. Ji Basit, go ahead.
सर जिम में जब ये होता है कि आपको जब स्वेट वगैरह और जो उसकी वजह से इन सेंसर्स को फ़र्क तो नहीं पड़ता आई गेस कि जब वाटर पेनिट्रेट कर दें सेंसर की वजह से उनकी फिट इनकी जो वर्किंग है उस पर ये उतने एफिशिएंटली वर्क करते हैं फिर उसके बाद
जी so I got your question. So his question is, चूंकि वो थोड़ी उनकी ऑडियो लो थी, उनका क्वेश्चन ये है कि जब आप जिम में जाते हैं तो यूजुअली यू स्वेट एंड यू स्वेट अ लॉट. दैट इज ट्रू. सो what will happen to the operation of this IMU if you are sweating a lot? So the answer is, at least in the data that we have provided, that is not an issue because the sensor was attached to a wearable. So wearable, by wearable I mean it is belt or glove, or it is an armband. It was attached on the top side of it. Okay? And these are battery powered sensors, so they are usually not affected by human sweat during the exercise in the gym. But yes, you are true. If you are using some sensors to record the activity of the person who is performing some exercise in the gym, for example, there are also some specific sweat sensors which are used. So if you're sweating a lot, it is going to change the readings of those sensors. So you need to frequently calibrate them in order to get a good, reliable signal from them. But for IMU, specifically for this project, the data is good. It is in high fidelity. By the way, we have also implemented this project. Actually, Hassan has implemented, your T. Hassan Amin has implemented this project. We have achieved a very good accuracy that you will have the chance to read it in the manual. And it means that the data is in good form and you do not need to worry about these things when you will be processing that data.
Okay, and a chance to beat the accuracy achieved by Hassan. So that's a chance,
Yes,
and
that's the challenge.
there's a challenge. That's an enormous amount of reward associated with it. Well, that's there in the handout. You can go ahead and read it. Qasim, I think you have a question. Qasim, you have a question? Go ahead.
He's not audible to me at
Okay,
least.
okay. So that's all right. So if there are no more questions, any other questions before we move to the next project? So Tahir, if you can stop sharing your screen. Um,
Okay.
so Dr. Aves is going to present the second project. Aves, I've made you a co-host. You can go ahead and share your screen. So
Yeah, I'm
Aves,
just doing.
yeah, so going to talk about ECG and detecting abnormal heart rhythms from data that they have collected, or for you to detect heart rhythms, abnormal heart rhythms for the data that they have collected.
Assalamu alaikum, everyone. I guess all of you can see my slides. You have a very much interesting first project description from Dr. Tahir. So we are in the same line because they are measuring fitness, and we are, if you remember my talk in the lab 6, that was on the next generation of biomedical electronics. So I'm talking somehow on a similar tone, and I will link the things with the previous talk. So the topic for this project is arrhythmia detection through ECG. So just bringing back you about the last my lecture, what's the healthcare when I talk about okay, what's happening in our clinics or hospitals. So I mentioned that okay, if you go 30 years back, 40 years back, you have a time machine, you go back and you will see something similar in your hospitals. And the same thing is happening nowadays. So that was one of the motivation that we want to do something different what was happening. And then we talk okay, we have some like a portable machines, but the portable machines are also just name portable, but still you have to go hospital and do all the things because doctors don't rely on that data. So the data reliability is of concern. That's why still you are limited to clinic or the hospitals. So when I talk what's next is like we want to work on the wearables or the next generation of biomedical electronics, somehow which Dr. Tahir was also mentioning about in have the fitness measurement. They were talking about the wearables where they have to wear some devices. So we are talking in the same direction. And then we talked about, okay, we want to go for the device miniaturization so that we can continuously monitor that data. Why continuous monitoring? Because the disease or the disorder take us there. Specifically, for today's talk, or for today's project, we are more focusing on the cardiovascular diseases. And the cardiovascular diseases are chronic. And you never know when the chest pain can happen, for example, just at an abstract level. So for that, we need to monitor if you are chronic cardiovascular patients. So for that, we need to have a continuous monitoring system, which should be very much small and should operate at a very much small device. So for the ECG, the solution somehow can be something similar, a patch sort of sensor, which you can just place on your chest, and it should be comfortable. That's why it should be very much small. You shouldn't, there is no need to remove it often. So, and you can just display your data or transmit your data to the caregiver, to the doctor, and the doctor have a live access to it. And the patient can himself take control of his health. So that's the overall motivation for today's project. And on top of it, again, if you recall, we want to achieve the maximum clinical impact. We want to have that biopotential signal acquisition, which is here. So if you remember in the biopotential signal acquisition, we have that ECG data or any data which we want to record, since all real-time signals are in analog in nature. So we want to extract those signals, and that process is known as biopotential signal acquisition. So today what we are doing, we have that ECG data, which is displayed here. So we have recorded not using a 10 lead system, using a single lead ECG system. So we have that data, and I'm going to provide that data for you. So your task is that to have that data and do some processing on the part of the feature extraction, and then do the classification. So if you remember the feature extraction, the purpose of the feature extraction was that you have some data, you cannot process all that data on, for example, even on wearable device or even on not on the desktop system. You want to extract those features which are going to be helpful for the classification of the abnormality you want to detect, something similar which was also discussed in the previous talk. So I will just elaborate a little bit in coming slides about these features which are going to be helpful, but there are certain amount of features which are used explicitly for the ECG or for the specific time of arrhythmia detection. And then after that, we want to classify. So classify whether the data is normal or abnormal. So in today's or for this project, we are mainly focusing on this feature extraction part and the classification. And with feature extraction, definitely some pre-processing also comes, which will amalgam the overall scenario. And the recording and stimulation is left for future, but you want to just see that, okay, how you are going to analyze that data. So for example, here we have some ECG data, which is being displayed here. If you can just see this ECG data, we have some patterns. I'm going to explain these patterns, and we not commonly call them as PQRS patterns. And then we have some abnormalities, which is being displayed here. One is PVC and one is VT. In today's lab, or in the project, we are going to focus on these two abnormalities, which is PVC and the VT detection. So moving forward, a little bit of introduction about the ECG, since we didn't talk much about the ECG, and this lab is, or this project is on ECG, and you need to know how the patterns are and what are the things and how you can detect them. So in general, your heart basically, which is being shown here, has 4 chambers. 2 chambers are down, which are known as ventricles, and 2 chambers are up, which is known as arterioles. So what happens basically, the blood pumps from the your artery to the ventricles, and during that pumping process, the heart, the blood pumps, there's a polarization and the depolarization happens, and during this whole polarization and the depolarization happens, there's a complete cycle happens, and that complete cycle is now commonly known as your those beat per minute or your pulse rate or your heart rate. So this, if you see this complete cycle which is happening here, this is one pattern in which the heart do polarization, heart do depolarization, meaning the blood is going to be pumped from your artery, it will go to the ventricles, and then it will forward to all your body, and the heart will go like this. So when you just do this movement, so one, this cycle is known as cardiac cycle, or we also call one pattern is a ECG pattern, which is basically displayed in this plot. And this ECG pattern is also have a specific waves, which is determined, which can be determined, and we normally call it as PQRSTU pattern. So every cardiac cycle is going to have one of these patterns, which we normally call PQRST pattern, or commonly known as QRS complex. Because in sometimes you have some of these names which are mentioned here, PTU missing, but the QRS is all the time available in any live person, means who is breathing basically, whose heart is working properly. So that's why we normally call this ECG pad, this ECG as a QRS complex, or this one cardiac cycle. And we want to identify basically some of the abnormalities based on this QRS pattern. If, for example, your QRS pattern is normal, your heart is behaving normal and everything is fine. But if there is some deflection, some change in amplitude of this QRS pattern, some change in amplitude of the interval of any of these variables or any of these names which are written here, for example, R, P, Q, R, S, T, you will find some issue with your heart, or you will find some issue with your health. And that is what we want to determine. And we normally call those as arrhythmias. So cardiac arrhythmia is a terminology which we normally use, that, okay, there is something wrong with your heart is not working as intended. So that's why we want to identify those. And how we can identify those? Deviation of these patterns, these amplitudes, these intervals from the normal wavelength, from the normal pattern. So that's what I'm going to explain in a couple of slides. So again, this is your arteria. The blood is going to move from the arteria. It gets activated to the ventricles, and then it's going to distribute to your whole veins. And that's one whole cycle of ECG cycle or cardiac cycle. Coming to this cardiac arrhythmias, if everything is fine, we normally call the sinus rhythm, which is shown here. So your heartbeat is normal. You have a complete, very much nice, at least QRS complex, which are repeating after a certain amount of time. And for each human being, those normally remain constant. For example, if you are a young and healthy individual, your beats per minute will be around 60 to 70 or 60 to 80 beats per minute in a normal routine, and they will remain consistent. It's not going to be, they will fluctuate from 60 to 70 in normal sitting time. So if this is happening, this means at least your heart at the first degree is behaving normal, and we normally call it a normal heart beat. If your heartbeat is beating a bit fast, crossing 100 BPMs, we normally call it a fast heartbeat patterns, or we normally call it tachycardia. That's something, if you run, for example, or you do some exercise, or so you will observe that your heartbeat is increased, and it might increase across 100 BPMs. And that's during the exercise, it's not dangerous. But if you're sitting calmly, you're doing normal work, and you feel that your heart rate is going beyond 100 BPM, that's something you need to visit a doctor. You need to consult some hospital. If you talk about children, small children, infants normally have beats per minute more than 100. So that's common, but I'm talking about a individual like you, or the fresh, or like in young age. And then comes another thing, which is normally called a slow heartbeat. If your heartbeat is less than 60 BPMs, then also there is something wrong with your heart condition, and we normally call it tachycardia. These two are still something which we can somehow cure by medication, or something not that much disaster, but something which is very much disaster is irregular heartbeat. When there is no fixed pattern, sometimes it's 60, sometimes even in a sitting environment, 70, then 80, then 100. There is fluctuation between this heartbeat. How we can determine this heartbeat? By these peaks. From this R to R peaks, there is an R to R interval, and variation in these intervals can cause irregular heartbeats. And that irregular heartbeats, which I now commonly call as arrhythmias, and here we are quoting them as cardiac arrhythmias. So that's what you want to identify some of them from today's or from this project. So normally we call this irregular heartbeat as cardiac arrhythmias. Moving forward, what is cardiac arrhythmia and how we can determine that? There are multiple basically arrhythmia types. We are not going to discuss all of them, but we want to just discuss some of them, that okay, how we can proceed, or how we can see some of the basic ones. So the common scenario comes, the QRS complex in these arrhythmias sometimes becomes white. Again, these are not like available in all patients. Some patients might observe this thing and some might not. So the QRS complex might become white, or there can be some deflection in the T wave. In the QRS goes opposite side, like for example, instead of having this pattern, we can have this pattern of ECG. Or there's an absence of a P wave, which was at the start of the QRS complex. But the good thing is that we can still detect all of these arrhythmia conditions with the help of some of the features which we normally call R wave, S wave, and T wave. So in today's lab, I'm just at this moment going an abstract level, that we are going to detect two types of arrhythmias. One is the premature ventricle contraction, which is commonly known as PVC. There are again multiple types, but we are going to talk about a very much simple type. So we're going to identify PVC. And then there's a second type, which is known as ventricle tachycardia, VT. We're not going to discuss some of the other arrhythmias, but today's lab or this project is basically going to focus on PVCs and VT detection. Now we need to see how we can detect this PVC and VT from a QRS complex. So if we talk about the PVC, PVC is commonly known as premature beat. So it's, if you have a PVC situation, that's pretty much common. All of us might have a couple of PVCs happening even if your heart is working properly. But to be cautious, we need to record them. The frequent happening of the PVCs is a bigger issue. And what it is basically electrical irritability in ventricle condition system or muscle or muscle tissue. So that's why something is related to muscle is not hurting, but when something is related to heart, then definitely that's something to be cautious. So for ease, I identify that in provided data, what are the causes, how we can detect the PVC. So for example, in a premature ventricle contraction, which is shown in this point, which I'm marking here. So if you see that PVC can have one or multiple of these conditions which I mentioned here. So for example, it can either have a short RR interval, meaning something similar to a tachycardia situation, or a long ST interval, or a high T wave amplitude. I'm writing it greater than 100 because in the database, the values are provided in the form of ADC codes. So you just at this moment go with an absolute value of 100. If something you find bigger than 100, you can go for, okay, that's this condition of the PVC. A little bit detail is provided in the manual. So you can just go through and you can come in the breakout session, or also we can follow up later in a specific office hours. So if you see this ECI pattern PVC, which I marked here, the red point are basically the R wave, which is being detected. So since it's a continuous pattern and we are going to detect each PQRS events, so this is a red one, the peak is the R wave. Then the dip, which comes just after the R wave, is an S wave, the local minima, for example. And after the local minima, between the next R wave, the peak which is going to come is going to be called as a T wave. So we can determine this R wave amplitude, R wave index, S wave amplitude, S wave index, and T wave amplitude and T wave index. If we can determine these three, I will call them as the features, we can at least easily identify this PVC. So premature ventricle contraction from an ECG data can be determined if we are able to identify the amplitude and the index of R, S, and T wave. Okay, so that's one thing which we need to understand. Then comes this is again a pattern from a hospital, which is showing basically the normal rhythms. These are normal QRS complex, and this is a PVC which is happening. Okay, so you can see a dip coming on. There's a small peak here, the dip, and then a peak. So this is normally called as a PVC. So if we move forward towards another arrhythmia condition, that is a ventricle tachycardia, which you also have to observe or evaluate in this project. So ventricle tachycardia, an extremely unstable rhythm, that's something which you need to be cautious about, that you might go into the sudden cardiac death. But again, it's not like directly if VT is going to happen, you are going to, but it will lead to. So how we can normally identify? The medical specialist normally called occurrence of 3 consecutive PVCs is something which you are leading towards VT. So normally they determine in the ECG pattern, if you are having 3 consecutive VT, 3 consecutive PVCs, then this means that you are moving towards ventricle tachycardia situation. So for example, in this pattern, this is a series of a VT, a series of PVCs. This means this person is almost like going to expire. It's not, his condition is not at all good. But in general, if you have 2 or 3 PVCs or 3 PVCs in consecutive, then we normally call ventricle tachycardia, and the person has to be dealt according to the medications, or a cardiologist has to advise whatever the next steps to be followed. So our main purpose is that whenever we want to do a device, we want that person don't have to visit the doctor, or these matrices can be identified, and he should be get an alarm. Now you should visit a doctor, and then the cardiologist's job come. Now he has to fix that person, or whatever the cure he has to provide to that one. So just for ease, I included only PVC and VT. So your life can be just a little bit relaxed, that, okay, we only need 3 features, 3 set of features, basically R wave amplitude and indices, S wave amplitude and indices, T wave amplitude and indices in a QRS complex or an ECG cardiac cycle. So for that, what you need to do is basically, first, the most important thing, you need to find heart rate and heart rate variability. Heart rate normally commonly is an average heart rate which you encounter over 1 minute, or even a bigger window, whatever you want to quote, or whatever the ECG pattern provided to you. So heart rate is something similar which you did in the PPG or lab 6, where you have the pattern, and I try to identify the local maximas from there, and then those local maximas over a certain duration you can relate to beat per minute, and that is your heart rate. So something similar here. You have an R2R variation, so you are going to identify the difference between each R to R, and then you average out over the whole duration of the patterns, and then you multiply with the 60 to convert into minutes. And then comes heart rate variation. As I was saying, it's very much important to measure the variation in the heart rate. If your heart rate is, for example, consistent at one place, that's fine. But if you have some pattern which fluctuates from 60 to 80, 60 to 90, then this means there is something wrong. So for example, that's what I want from you. You have an ECG data and you need to do basically heart rate variation, meaning in the beats per minute, plot the heart rate which is happening with the respect of each individual. So the x-axis should be time, the y-axis should be showing the beats per minute. So that's one thing which we can easily do with an R2R variation. So if we have a feature which is just measuring your R wave indices, you can measure the difference of each individual and you can do the heart rate and heart rate variation. So that makes your life simple. It's something similar to what you have done in the lab 6. But then comes for the PVC, premature ventricular contraction. What you need to do, you need to know again R2R variation, because one of the features was relying on the R2R short R2R interval. So that you have already done, but you also need something else. That is the ST interval. Why? Because the ST interval should be, if ST interval is greater than 0.28 second, then again you are in a condition of a PVC. So for that, you know the indices which was evaluated in the features above, S wave and T wave indices. You can find the difference of them and you can find the ST interval. So that's why these ST indices are very much important. And then the third feature is T wave amplitude. Why? Because in the PVC, one of the condition was that if the T wave amplitude is bigger than a certain value, which was set as 100 in this data, then again you are going to have a PVC condition. So any of these two conditions basically will lead to PVC, a positive PVC. So these are the things which you need to do. Now for that, you need to identify these features, R wave, S wave, T wave. So that's something important which we need to do, and how we normally can do. So since you don't have to find only one local maxima, you have to find one local maxima. And then once you have find one local maxima, you have to search in a certain window another local minima. That is going to be called as your S wave. And once you have find an S wave, you have to identify another local maxima within a small window. So हमारे पास जो complete एक cycle बनेगा, इस cycle में you have one local maxima, then you have local minima, and then you have local maxima. So for that, you can only move forward once you have done first local maxima search. तो इसीलिए we are defining a state machine. State machine क्या होती है? आप एक box के अंदर जाएंगे, for example. Once you go into that box, then you can go into the next box, and then you can go into the next box. So it's basically a hierarchy है, उस hierarchy के अंदर ही you can go inside. So state 1 is first box, and then once you go into the state 1, then you can go into the next state, and then after that you can go into the next state. So in that case, you can identify all those these local maxima, minima, and local maxima within a certain box, which I am calling a cardiac cycle, and you have to continuously repeat this thing for the whole duration. So you can go through a little bit this state flow diagram, and you can come in the breakout session. A little bit description is provided, but if I just go through, might not be that much understandable. But I would highly like go through and then come in the breakout session or in the office hours. We can definitely discuss. But ultimately, the logic is simple. You just go inside one box and another box and another box, and ultimately you come out of that boxes. Okay. And just to identify, this is the name of the state. So state 0 means it's a 0 state. And then whenever something is written in this like a triangular shape, is going to be the decision. So we are finding the local maxima. And then once the local maxima, we are saving the value. And then based on this local maxima, we are going to decision, we are going to the next state. And something similar will follow for all the states. So coming to the overall tasks, we have again identified. I'm just going through a little bit quickly through the tasks. But again, you can just go into the detail and you can come. So I don't want to take more time since you have another project description which is going to be followed up. So you have first task where you have to just do the simple similar thing of data plotting and analysis. You have two data provided. One is case 1, ECG underscore case 1, and ECG underscore case 2. So you have to download both of these data, and then you have to plot them, see them whether there are any arrhythmia patterns available or no. So the first task is basically you have to manually see whether there is arrhythmia patterns available or no, and then you just need to report them and also you need to identify those things which I was mentioning, the features that, okay, if there is a PVC, what is the condition of PVC? If there is a VT, what are the condition of VT? So also link with those feature values. So you might have got something similar to this plot when you do at least case one, and then you can see, okay, whether it's a normal pattern or not normal pattern. You can zoom in and then you can get and observe the same PQRST pattern. So for example, there's a PQRST pattern which is noted down here. So moving forward, the task 2 is again the heart rate and heart rate variability. That's again something I guess all of you can easily do. So it's same thing as a lab 6, where you have to find an average heart rate value and then you have to report the heart rate variability. So ultimately what I want that you do some pre-processing, and after that pre-processing, getting rid of the noise and the DC value, you report the average heart rate value, and then the heart rate variability plot something like similar to this one. So you need to report, okay, there is a variation or no. So might be your data don't have any variation, but if you don't, still you have to plot that line of the heart rate of the beats per minute variation. Okay? So that's task 2 again. So I would say task 1 and task 2 are like a piece of cake for all of you. Since all of you have done these things, you just need to apply the same techniques on a different data, which is normally ECG. After that, we are moving toward the task 3. So for the task 3 is basically feature extraction. So I divided these feature extractions into 2 tasks, basically one for the case 1 and one for the case 2. So that makes your life easy. So the case 1, I would say the feature extraction is a little bit easy. So if you are follow that state flow diagram, you can implement that state flow diagram, and you need to identify basically the R wave, Q wave, and S wave amplitude and indices on the plot, something similar which is shown here. So you need to just, on the ECG pattern, you have to mention where the R wave peak is coming and what is the index. Where the S wave peak is coming and where is the index, and the same thing apply for the T wave. So you need to identify all of these things basically, and also in the text and also on the top of the plot. But you have to do only for the case 1. So once you are done with that thing, so the ultimate zoom in version is also shown here, so you can identify easily these things. So you should be able to detect all of these PQRS complexes, RST wave perfectly. At least for this feature, for the case 1, you should be able to. That shouldn't be a daunting task. After doing this thing, you should move toward the task 4, which is doing the same thing for the case 2. A case 2 a little bit is abnormal data you can also observe. So that's what you need to do. So make sure you don't miss any of these things. So for example, if I just start from here, this first is the R wave, then you have here S wave, then you have here T wave, then again the small one is again an R wave, then you have a dip which is an S wave, and then you have a T wave. So make sure your algorithm or your state flow diagram detects these things. So might be you have some issue here, so you might need to go through your coding or your logic again, but make sure you need to do this thing, and you should be able to again detect all of these complexes correctly, and you have to report the data properly, since that's going to be used in the next step. So you have to report the S, R, and T wave amplitude and indices. So once you're done with that thing, your life is easy. You just need to do the classification, which is detection of normal and abnormal data. So how you're going to do that thing? You just have to basically see those patterns, and based on that, जो आपको पहले condition दी हुई है how to detect a PVC or how to detect VT. So if you don't find any, for example, in both case 1 and case 2, you just need to display that, okay, no arrhythmia detected based on those R, S, and T wave amplitude and indices. Also, if you find some issue, if VT or PVCs are detected, you need to report them in such form that, okay, PVC is detected at what seconds. If there are multiple, you have to report those. If you have one, you have to report that. But again, also mention the time, and also do the same thing for the VT. So that is basically the task 5. So I would say the main daunting task might be if you develop your task 3 algorithm very much nicely, your life will be a bit smooth. But task 3 and task 4 are more tougher. The task 5 is also just like ultimately closing up the loop. So this is, I guess, these checkpoints are already shared with you. So that can be discussed in individual meeting. But if you have any question, any query, please go ahead. I'm available. Otherwise, and also I will, I guess Dr. Momin will share the Zoom individual link for the breakout. I will also be available there. Thank you again for your attendance, and looking forward to work with all of you.
Okay, thank you, Dr. Wes. If there are any questions, we can just we can take one or two, and if you have more questions, we can take them in the individual meetings as well. So, Wes, meanwhile, if you can unshare your screen so that Hassan.
Yes, I can. Fine.
Yes. So Hassan, I made you the co-host as well. So Dr. Hassan is going to present the third project, which is on multi-agent irrigation games. So the game's title is really interesting. Maybe you can have a long conversation with Hassan what is meant by games. So it's game theory, all applicable to हमारे किसान भाई and irrigation and so many other problems. So over to you, Hassan.
Okay, thanks, Momin, and thanks everyone for coming to this session. Or it's really difficult to actually follow these two great presentations by Tahir and Awais, and these are excellent projects. And the flavor of this project that I'm going to present, it's going to be a little bit different. So think of the previous two projects in the sense that they are based on, they are built upon hundreds of years of research on how human body works. And now we know that कि आपका heart कैसे काम करता है, आपके different muscles, आपकी body motions, how they operate. Now, as engineers and technologists, we started making sensors that instead of a doctor who is kind of analyzing it, these sensors are doing that job. Now, in this project that I'm going to present, we are actually, this is related to another aspect of human, and that is how humans make their decisions. And if we can somehow understand how humans make their decisions, this is, you can imagine how useful that is going to be for any government or any policy making institution for making the different laws, different policies, and all that stuff. But at the same time, human mind is the most complex thing. And we are not here talking about just one human. We are talking about a large number of humans who are living in a societal or a policy or in a population setting. We are still far off in claiming that we know how human mind works. So, but still the research has been going on for a long time, and there is something that we can still say. So the project is based on your last lab in which we talked about this irrigation, and Dr. Abu Bakr explained to you the importance of irrigation, especially in the context of Pakistan, but as a humankind in general as well. So the feedback I got, it was good that most of you were able to do those lab tasks easily. Hopefully in this project, you will have to up your game to participate in the game of irrigations. So here is, let me just start with, I haven't prepared a PowerPoint show, but let's see. I will just go over this lab report, जो कि आपका जब lab handout है, and we will just go through what's happening. So here is, let me adjust the size here. So this flow diagram over here, this actually highlights what we did in the last lab. And that was, you have a single farmer, and that farmer has installed some kind of and the farmer wants to know when he should irrigate his land. Or in order to help him in that task, he has installed some kind of a soil moisture sensor. He has also installed or has taken help from a weather station to get a forecast on when is it going to rain. और इस सारी इंफॉर्मेशन के बाद ये रेन जो है ये एक अनसर्टन इवेंट है, सॉइल मॉइस्चर जो है ये आपको आपकी ट्रू डिमांड के बारे में बताता है. So based on this information, and there is this storage of water, the farmer then looks at this information, okay, what is the demand, what is the situation of rain look like, and then he decides whether he should take the some water from this storage or not. Okay, so that was an ideal world, and you guys have looked at the simulations and how these things और किस तरीके से आपकी yield जो थी वो effect हो रही थी इससे. In any practical setting, it's not going to be a single farmer जो कि एक water storage से पानी ले रहा होगा. इनफैक्ट अगर ये जो आपके सामने ये एक जो स्ट्रक्चर सा नजर आ रहा है, दिस ये नाला, इसको आप कहेंगे, खाला कह लेंगे, जो भी कहेंगे, those of you who have a background, agricultural background, they will know this very well कि एक जो एक खाला होता है, इसके ऊपर 40 फार्मर से लेकर कोई more than 100 फार्मर्स होते हैं जो कि एक सिंगल स्टोरेज से पानी यूज कर रहे होते हैं. Now, how is that going to affect the decisions of the farmer? So let's look at this simple scenario. Suppose आपके पास दो फार्मर्स हैं, फार्मर 1 and 2, और वो दोनों किसी एक स्टोरेज से पानी ले रहे हैं. So farmer 1 is very progressive farmer. He has installed some kind of a soil moisture sensor, और उसके पास उसकी ट्रू डिमांड आती है. लेकिन फार्मर 2 जो है, he is a traditional farmer, वो उसने कोई ऐसी टेक्नोलॉजी इंस्टॉल नहीं की हुई. So like what we had last time, हमारे पास हर दिन के हिसाब से हमारी डिसीजन होती थी. जो एक सीजन है उसके हम एक हर दिन डिसीजन लेते थे. तो ऑन सम डे वाटर सप्लाई जो है, अब समझें कि आपके पास पीछे जो स्टोरेज है उसमें सिर्फ एक बारी का पानी रह गया. जो फार्मर 1 है, जो कि प्रोग्रेसिव फार्मर है, उसने अपने सॉइल मॉइस्चर सेंसर की रीडिंग को देखा और उससे उसको पता चला दैट ही डज नॉट रिक्वायर वाटर टुडे. हिज वाटर लेवल इज सफिशिएंट मॉइस्चर लेवल. ही इवन डज नॉट रिक्वायर मॉइस्चर टुमारो, क्योंकि उसका मॉइस्चर लेवल इतना है कि जी वो कल भी सर्वाइव कर जाएगा. बट ऑन डेज T+2, यानी कि आज से 2 दिन के बाद उसको पानी की जरूरत पड़ेगी. तो वो ये डिसाइड करता है कि जी अच्छा, उसको पानी नहीं यूज करना चाहिए. सो ही डिसाइड्स नॉट टू इरिगेट हिज लैंड ऑन दैट डे. अगले दिन क्या होता है, जब फार्मर 2 है, याद रखें उसके पास कोई सॉइल मॉइस्चर सेंसर नहीं है, वो बस पानी अप्लाई कर देता है अपनी फसल के ऊपर, और वो दोनों एक ही स्टोरेज से पानी ले रहे हैं. और now that farmer 2 has used his that water, now that water is finished. अब फार्मर 2 ने ये डिसीजन कैसे लिया? हो सकता है उसको जरूरत हो पानी की, एक्चुअली हो सकता है उसको जरूरत ना हो, बिकॉज ही डज नॉट हैव एक्यूरेट डिमांड. उसके पास किसी किस्म की टेक्नोलॉजी नहीं है. वो एक ट्रेडिशनल वे से बस के जी ओके, आई नीड टू इरिगेट माई लैंड टुडे. लेकिन फार्मर 2 के इस डिसीजन का फार्मर 1 पे क्या इफेक्ट हुआ? फार्मर 1 पे उसका ये इफेक्ट हुआ कि अब जब 2 दिन के बाद फार्मर 2 को पानी की जरूरत पड़ी और दरमियान में बारिश नहीं होती, अगर फार्मर 2 के पास अब पानी नहीं रहा. अब नाउ दैट्स वेयर द इशू कम्स अप. आप अगर इस सिचुएशन में होते फार्मर 1 की जगह, तो क्या करते? आपका डिसीजन डे टी के ऊपर, अगर आपको पता है कि इस किस्म की सिचुएशन हो सकती है, व्हाट वुड हैव बीन योर डिसीजन?
So can I answer the question?
Yeah, sure, go ahead.
So in that situation, I would have used the water. First of all, I would have made an agreement with that farmer that this is the amount of quantity of water that we can use on second day or third day. And of course, this scenario, what I would have done is that I would have used that water on second day when my moisture level is decreasing.
Okay, so you have raised, it's Qasim, right? So Qasim, you have raised very interesting points. So there are two things that you have raised. First of all, that you have actually talked with the other farmer, और उसके साथ आप किसी किस्म का एग्रीमेंट पे negotiate करते हैं कि every
Water
other
distribution equity. So that is called water distribution equity.
Okay, that's fine. और दूसरी आपने बात क्या की थी? Second point क्या था आपका?
My second point is that if that farmer is not willing to do that water distribution equity, then what is possible that I can use my share, because I have the senses on the land. I can sense that I don't need the water for the first day. That second farmer is using my water on the second day. So on second day, I also don't need that water because my moisture level is good enough. But at the same time, when my moisture level is like substantially decreased on the second day, mid second day. So I use that water of my share on second day so that it is equivalent on third day also. So I don't need water on third day also using the same moisture level.
Okay, that's good. So that's actually very good. So the point is there are one comment that I can make is that there is no one solution here. And secondly, this problem is complicated, that either if the two of the farmers, they can reach an agreement, then it's good. If they cannot reach an agreement, then it's something going to be a war. It's kind of everyone will be selfish, or जैसे ही आपको पता चलता है, you will try to get water. Now, this is just 2 farmers. Think about the case where you have 100 farmers. Now, think about the
Sir,
case where you have hundreds of farmers. Yes, go ahead.
sir, what I know personally, that in that scenario, what the governments, the local governments and the provincial governments do is that they have a water tax rate that is probably called Abhyana, something like this.
Yes,
So
yes,
what
yes.
they do is that they like calculate it for every farmer, and when they calculate it, and when the government knows that if this particular farmer is paying me and this particular farmer is not paying me, then the water regulation for each and every farmer is possible. So this is one of the kinds of the solutions I can refer to.
That's great, and that's actually यही हमने इसके अंदर लिखा भी हुआ है. But you are exactly right. So the point that I'm trying to make here is, or very well put down by one of your colleagues as well, that something has to be done here. It's not something that you can just leave it here. Water is such an important issue, and these kind of problems are so important that there have been actually over the years several Nobel prizes have been like granted based on to the researchers who have been working on these problems. So Professor Eleanor Ostrom, she is one of the last ones who received a Nobel Prize precisely on this particular problem of how to manage common pool resources. Common pool resource like water, there is a common source of water, but there are a lot of people who want to use it. And her thesis was that, okay, normally the context is that it has been argued कि जी अगर आप एक कहीं पर भी common pool resource होगा, everyone is going to start behaving selfishly or try to use that excessively. And as a result of that, the common pool resources going to get depleted very fast. And this is what is called as tragedy of the commons, that people behave selfishly. Her thesis was that this is not what going to happen. And she actually showed through a lot of historical evidence and current evidence as well that when people are faced with calamities such as water shortages, they cooperate with each other to find solution. And that's what her suggestion was, or उन्होंने हर सारे इसकी ऊपर ही she worked on this idea that local people should be enforced to reach their conclusions or reach these decisions themselves, and then the government should just be there to facilitate and implement those things. So people are themselves, they should be able to make these decisions. So that's why the point that I want to make here is that this irrigation related problem that you were exposed to in your last lecture and in this project, this is one of the most fundamental problems in the world, one of the most fundamental problems. And there are great minds in the world who are working on addressing how to actually solve these issues or address these issues in a fair manner or just manner. Now, the other interesting thing is that remember, go back to your previous lecture, और उसमें आपने देखा होगा कि जी एक कोई physical phenomena था, and we modeled that physical phenomena using some kind of a differential equation. हमने एक mathematics के language में उसको represent कर दिया था, और उस mathematics that language of mathematics actually helped us in designing or understanding that phenomena. Now, the mathematics or the mathematical modeling framework that we discussed last time, if we look at it, we looked at it for irrigation problem. But let's say you want to change your hat and now you want to become a pure engineer, और आप कोई roboticist की hat आप अपने सर पे पहनना चाहते हैं, and now you are working in an Amazon warehouse where you have hundreds of robots who are now in charge of this warehouse, or this is a fully automated warehouse of Amazon, जिसमें robots are taking these different articles from one aisle to the other and from one delivery to the other, and they are doing all these tasks without any human intervention. How they are doing it, there is some kind of mathematical models, some kind of controllers, some kind of decision systems that are at the back of it. And the interesting thing is that the kind of work that Ostrom did, or people who do in economics and political science did, the kind of models that they developed, in spirit, the similar kind of models are actually governing how these robots are going to move. So अगर आप इसको abstract level के ऊपर in terms of mathematics देखेंगे कि how different agents are going to interact. Irrigation games में वो agents कौन है? वो humans हैं. इस सिचुएशन में जहां पर ये एक आपका रोबोटिक वेयर हाउस था, यहाँ पर वो एजेंट्स कौन डिसीजन ले रहे हैं? वो रोबोट्स डिसीजन ले रहे हैं. Robots are, one robot is affecting the other robot. So the beauty of this framework, the system thinking that we discussed last time, it actually allows you to study these two very different problems with the same set of tools. So even in this project, the things that you are going to develop, और जो आपका जो tasks होंगे, आप अगर वो इरिगेशन गेम के नाम की जगह वहां से निकाल के आप उसके पीछे ये कह देंगे, ओके, हाउ the robots are going to arrange some kind or distribute some kind of resources, your framework will exactly fit in. So this is the main idea that I want to make sure कि आप लोगों के जहन में ये भी बात आता है कि ये जो systems thinking है, it actually allows you to look at different applications with the same set of tools. आप उसकी जो thinking है वो similar thinking की base के ऊपर उनको address कर सकते हैं. Okay, so what are we going to do in this particular topic, जो आपका task है? अभी हमारे पास अभी आपके वन कोलीग्स बता रहे थे कि हाउ इज द इरिगेशन प्रॉब्लम करंटली एड्रेस्ड इन पाकिस्तान. यू हैव अ लार्ज नंबर ऑफ पीपल ओवर देयर, और उसमें देयर इज अ सेंट्रल प्लानर जो आपका इरिगेशन डिपार्टमेंट होता है. दे हैव टू इंश्योर दैट द वाटर इज समहाउ फेयरली डिस्ट्रीब्यूटेड. And how is that done here? Currently, the system, this is called as a Varabandi system. Anyone knows what Varabandi means? Have you heard about Varabandi before? So Varabandi is actually an Urdu term, and it means turn by turn. That's right. ये Vara means बारीक इसकी, और Bandi means a fixation. So Varabandi means that there is a fixed schedule जिसकी base के ऊपर पानी distribute होता है. So who is designing this fixed schedule? Yeah, actually it dates back to the British era, और उसके बाद 60s 70s में ये design हुआ था. And now your local irrigation department is actually going to enforce this thing. Now the positive side of this fixed schedule is कि farmers को पहले से पता होता है उनको पानी मिलना कब है. ठीक है? So they can actually design their irrigation activities based on that fixed schedule. तो मुझे पता है कि अगर 10 दिन बाद मुझे पानी मिलना है तो मैं अपनी क्रॉप की सोइंग करूंगा ही इसी हिसाब से कि 10 दिन के बाद पानी की रिक्वायरमेंट हो. The negative aspect is कि इस सिस्टम में कोई फ्लेक्सिबिलिटी नहीं है. It's fixed. अगर मुझे आज पानी नहीं भी चाहिए फिर भी मुझे पानी मिलेगा, और वो पानी अगर मुझे पानी 2 दिन के बाद चाहिए था, मुझे 2 दिन बाद पानी नहीं मिलेगा. So Shazar, you have raised hand. Go ahead.
Sir, am I audible?
Yes, go ahead.
So, sir, I want to ask, let's say at any particular day there is a rainfall for a certain farmer. ठीक है, उसकी water requirement उस दिन पूरी हो जाती है. So how about we make our program, design our program in a way कि if there is a rainfall या highly probable rainfall होना है किसी दिन, और उसी दिन उसके यहाँ irrigation और water supply जा रहा है, तो we can substitute that water and save that water from irrigation. तो सर
Shazar, you have actually very well explained your task, one of the tasks here in this project. So that is
And sir,
precisely going to be your task.
So similarly, I found some sort of confusion in previous lab task for bonus one. Sir, I want to ask, how about if I just change my mathematical programming in a way कि हमें पता है कि हमारे पास वाटर आ रहा है, रेनफॉल अगर आज के रेनफॉल मिलेगी, ठीक है, अगर हम इतना पानी बस अपने फार्म एरिया को दें ताकि वो वाटर और रेस्ट ऑफ द वर्क रेन विल डू. तो सर हमें नेक्स्ट डे की क्या जरूरत पड़ी है अगर हम इस तरह डिजाइन करें कि बस इतना पानी दें ताकि बॉटम स्ट्रेस लेवल से थोड़ा सा ऊपर, तो हमें अगले दिन की रेन की क्या जरूरत पड़ेगी?
Okay, so very well. So अगले दिन की रेन की क्या कब जरूरत पड़ेगी? I think that's a little bit more involved कि जी अगर आपका आज का पानी इतना है कि जी आज आपको पानी की जरूरत नहीं है. ओके, सो 2 दिन एक्चुअली उसकी जरूरत आपको उसको पड़ती है अगर आपको रोज पानी अवेलेबल ना हो.
Alright.
अगर आपका जो वाटर की इनपुट है, लेट्स से वो इस अभी लेट मी एक्चुअली गो ओवर द टास्क नाउ, और ये चीजें आपकी एक्सप्लेन होंगी. ठीक है?
Sure.
So after
वैसे भी
that
थोड़ा सा
we can.
irrelevant है थोड़ा सा
Okay.
यहाँ
No,
पे.
it's not irrelevant. It's actually directly relevant to the tasks here.
Okay, okay, okay.
It's very relevant. So
Okay, thanks,
अब ये
thanks.
एग्जैक्टली यही बात हम यहाँ पर कर रहे हैं कि जी फिक्स स्केड्यूल है. सपोज फार्मर 1 की बारी थी, आज फार्मर 1 की बारी थी और कल फार्मर 2 की बारी होनी है, लेकिन आज ही अगर एक दिन पहले बारिश हो जाती है तो फार्मर 1 को पानी की जरूरत ही नहीं है. और इट वुड हैव बीन बेटर कि अगर फार्मर 1 और फार्मर 2 अपनी बारी एक दूसरे से स्विच कर लेते. लेकिन जो आपका फिक्स स्केड्यूल है वो आपको ये चीज अलाउ नहीं करता. सो दीज आर द इश्यूज दैट आर देयर इनहेरेंट इन दिस फिक्स स्केड्यूलिंग. And Kasim, you go ahead.
Sir, I would personally disagree that this is the drawback of the system of
Mhm,
turn by turn water distribution, because
mhm.
there
Kasim, I cannot hear you. Kasim, I think there is issue with your internet. I cannot hear you.
So Hassan,
So
perhaps, I mean, these specific issues we can take care of in the individual meetings as well.
exactly, yeah. So yeah, so Kasim, let me finish this, and afterwards, if you have this question, we will have this discussion. I would like to have this discussion with you, or we can take that later on. So I will just want to explain that what are going to be your task requirements in this project. So in the first project, आपके इस project के दो parts हैं. The first part is that you have to develop a MATLAB code for a scenario in which you have 4 farmers. Last time आपने जो code develop किया वो single farmer के लिए था. अब आपने ये 4 farmers के लिए डिजाइन करना है जिसमें हर farmer जो है वो एक दूसरे से different है. In terms of their yield decay rate, the yield decay rate किस हिसाब से था कि वो उनकी crop जो वो sow कर रहे हैं उस पर dependent है. Similarly उनकी soil type different है. So ये आपको टेबल में यहाँ पर given है कि farmer 1, 2, 3, 4 की types क्या है. So your first task, as I just said, is to design a fixed schedule for distribution of irrigation among the farmers. आपके पास एक storage में total amount of water fix given है, I total. हर farmer को हर जब भी उसकी बारी आएगी एक fixed amount of water आप deliver करेंगे, और जो schedule है आपका distribution का वो fixed है, और वो इस तरह है कि जी आप farmer 1, 2, 3, 4 every 21 days, हर तीसरे हफ्ते आपने पानी distribute करना है based on this schedule. So ये आपका first task होगा कि आपने इसके लिए अपना complete MATLAB code develop करना है. जो second आपकी जो lab होगी जो उसमें आपने क्या करना होगा, इस fixed schedule की जगह आपने एक demand based schedule propose करना है. और इसमें भी यही है कि आप you have a central planner, और वो central planner सारे जो farmers हैं उनके soil moisture readings को measure कर सकता है, और हर 7वें दिन वो किसी एक फार्मर को पानी देगा on every 7th day. Now the question is वो किसको देगा. फिक्स स्केड्यूल नहीं है, वो डिमांड्स को देखेगा और उसकी बेस पे. Now even in that level there has to be some measure of fairness कि वो वाटर को किस तरीके से डिस्ट्रीब्यूट कर रहा है. फेयरनेस को डिफाइन करना, दिस इज वन ऑफ द वेरी डिफिकल्ट थिंग्स टू डू, क्योंकि डिफाइन आप कर सकते हैं, उसको एग्जीक्यूट और इंप्लीमेंट करना बड़ा इट्स अ डिफिकल्ट थिंग. However, what we can tell for sure is what are unfair means. So for instance, अगर सारा पानी आप किसी एक ही फार्मर को दे दें तो this is definitely not fair. Similarly, अगर एक ऐसा फार्मर है जिसको पूरे सीजन में पानी ही नहीं मिलता, of course that is another example of unfair mean. So in this task आप अब इस चीज प्रॉब्लम के ऊपर सोचें कि जी what should be the measure of fairness. There are different measures. This is an open-ended thing. आप लोगों ने इसके ऊपर खुद सोच के उसके बाद you will actually have to write a short paragraph कि what in your mind is the right measure of fairness. और उसके बाद आप अपना MATLAB कोड डिजाइन करेंगे जो कि उस measure of fairness के रिस्पेक्ट से को अचीव करे आखिर में. So this is a little bit an open-ended type, और वो आपके this gives you an opportunity to think about it, read about these problems, that how actually different people or different practices are going around the world. In the second part of this task, now there is a little bit difference now. और यहाँ पर अभी पहले comments में मैं देख भी रहा था कि tankers की बात हो रही थी, और वो इसमें यही है कि जी अब farmers के पास जो water की shortage नहीं है, पीछे से आपके पास think about it कि आपके पास unlimited supply है, एक फार्मर जितना पानी चाहेगा उसको मिलेगा, बट नाउ ही हैज टू पे फॉर इट, उसकी एक यूनिट प्राइस उसको पे करनी पड़ेगी. सो अगेन ऑन एवरी 7th डे हर फार्मर सेंट्रल प्लानर को बताएगा कि जी मुझे पानी चाहिए, और वो बताएगा मुझे कितना पानी चाहिए, और सेंट्रल प्लानर उसकी वाटर रिक्वायरमेंट पूरी करेगा, लेकिन फार्मर को उसके साथ प्राइस भी पे करनी पड़ेगी. अब क्या है कि फार्मर को एट द एंड ऑफ द सीजन फार्मर हैज टू सी कि अच्छा उसकी टोटल यील्ड कितनी हुई है, ये उसकी इनकम थी, और उसकी कॉस्ट कितनी आई है, एंड वी आर टॉकिंग अबाउट कॉस्ट इन टर्म्स ऑफ वाटर कॉस्ट ओनली. तो उसका प्रॉफिट कितना है, टोटल यील्ड माइनस कॉस्ट. एंड ऑफ कोर्स द ऑब्जेक्टिव ऑफ एवरी फार्मर इज नॉट टू मैक्सिमाइज हिज यील्ड. फार्मर की हमेशा जो ऑब्जेक्टिव ये होता है कि उसने अपने प्रॉफिट को मैक्सिमाइज करना है. सो सिर्फ ये कह देना है कि मुझे बहुत ज्यादा पानी मिल जाए, दैट इज नॉट गोइंग टू हेल्प यू. सो यू एक्चुअली हैव टू डिजाइन दिस स्ट्रेटजी, दैट व्हाट इज द राइट स्ट्रेटजी फॉर ईच फार्मर, कि how much water he should get or demand on every 7th day, such that the maximum profit is maximized at the end of the season. तो और इसमें water price is going to play a very crucial role, और वो हमने यहाँ पर आपको 2-3 ये different scenarios बताए हैं. For each of these things आप देखेंगे, आखिर में अपने वही simulations run करेंगे, and comparing those results you will actually write a small like 1 paragraph or 2 paragraphs कि जी क्या फर्क पड़ता है इस प्राइस बेस्ड मैकेनिज्म का, उससे पहले जो आपका फिक्स स्केड्यूल या फ्री वाटर मिल रहा था आपको, लेकिन उसके अंदर आपके स्केड्यूलिंग के इश्यूज थे. सो दैट्स व्हाट यू विल एक्सप्लोर ड्यूरिंग दिस प्रोजेक्ट. So that's where I will stop, and if you have questions, maybe we can do that during the office hours, or maybe 1 or 2 questions right
Maybe
now.
I think we can take 1 or 2 questions now.
Okay.
If there are any. Jihania, go ahead.
Sir, you said कि जो second वाली task में there is an unlimited supply of water.
Yes.
Is that also the case in the first?
No, no. In the first task, the supply is fixed.
Okay. Okay.
ठीक है, वो फर्स्ट टास्क की जो सप्लाई है वो यही है जो आपके प्रीवियस लैब 1 के अंदर.
So we just have to find कि what would be the fairest way to distribute.
Exactly.
All right, Qasim, do you have a question? Go ahead.
Yes, I have a question. Sir, there are 2 parts for this project number 3. So I wanted to ask that when we are designing this demand-based distribution system or strategy, like in my mind there are more than 5. So is it possible that instead of just designing one in the MATLAB programming system, I design 3 or 4 at least to give a lot of like different innovation to it?
Sky is the limit, my friend. You are free to do whatever you want. That's why there is the only thing that I require is it should be fair and reasonable. Okay? And whatever distribution mechanism you can think of, and आपने उसके पीछे जरा justification provide करनी है that in what context it is fair. Okay?
Right, sir.
And whatever you want to do, go ahead.
Thank you, sir.
Okay, so Hassan, if you could stop sharing I just want to show us just one thing here before we break. Okay, so I just want to put up some deadlines here, and this is a schedule that is common to all of the projects. So the deadlines are, as you see on the table here. So you would have to make your groups and decide on a project and send us an email to Hamza by Monday 5 p.m. So next Monday 5 p.m. you should have your groups ready. You should have decided upon what project you're going to take up and send us that, right? So the next Friday, which is the next lab, 6 p.m. is a deadline for checkpoint 1. And each one of the 3 projects has defined in their checkpoints what those checkpoints exactly are. So that you'd have to go through the handouts to figure out KT checkpoint 1 say. Checkpoint 1 is due next Friday, 6 p.m. Checkpoint 2 is due the next Friday after that, 6 p.m. That's the second last day of the semester. And the last day of the semester is when you would have to submit all of your code by 8 p.m. on LMS. For each checkpoint, you would just have to show that to your TA. and we're going to assign each group with a dedicated TA, right? And with this, and there's a demo video optional, which is completely optional. But if you want to really illustrate what you have done to help the TAs or help us, and perhaps have it featured on the department social media webpage, so you're more than welcome to make a video recording of what you have done. Okay. Now, what we're going to do now is I've sent an email to the entire class listing out the 3 individual meetings for each one of the projects. Project 1 meeting available is going to be headed by Dr. Muhammad Tahir. And he is going to answer specific questions that you may have about Project 1. And then Project 2 is Dr. Uwais, and Project 3 is Dr. Hassan. And you're more than welcome to jump in between. I mean, you go from one to the other. Just keep in mind that the instructors are going to be there for about an hour, right? So till about 5:30. If you join before 5:30, they're gonna address your queries. Don't plan on joining after 5:30. Okay. So with this, if I can ask the instructors to join their respective meetings, this is going to stay active. I'm going to be here to answer any specific queries about, or general queries rather, about the project per se, or specific queries about each one of the specific projects. वो फिर individual instructors answer करेंगे. ठीक है? All right. So I don't see Awais here. I think Awais has already left. Tahir has already left. Hassan has already left as well. So, and may I also request that all of the handouts are available on LMS. Give it a brief read first before asking queries. So वहाँ पे सारी की सारी details मौजूद हैं. Okay. So Abdullah Ahmed says, is it not possible to do the project alone? Not, if we don't encourage doing it alone. It's better that you find a teammate. In case you're not able to do that, let us know and we'll try to work through it. Okay. So Umar, what is that for? I mean, is it not possible to do the project alone? Is that, uske response mein ha?
Inside joke, sir.
Right, so inside joke, just keep it in the inside, please. Not on the outside, right? Okay. So I'm going to break for Asar, for 5 to 10 minutes. उस वक्त तक जो है, so Awais is still here.